Hello everyone. In this video, I'm going to demonstrate how to use BatQ. BatQ is software that I wrote to simplify access to Batfish. Batfish is software, open source software that was designed to take configuration files of a network and analyze them. Right. Usually, Batfish requires access using Python code, but I used Streamlit um, framework to build BatQ and makes access to Batfish easier by providing user interface, a web user interface. BatQ is a good tool to do a quick check for network configuration or do quick troubleshooting. Right? And for that, I think it's going to be a useful tool for anybody who wants to learn Batfish quickly and easily. Okay, so Batfish is not a complete replacement for the Python code or for to extract all the applications and all the benefits of Batfish, but it has capabilities. First of all, it provides an easy access to Batfish. For someone, it lowers the learning curve and make access to Batfish a lot easier. It provides user interface, uh, a web user interface, does not require any coding, but at the same time, it doesn't provide the full range of Batfish capabilities, right? And it doesn't provide any printing capabilities for now. So you are limited only to accessing the web interface. Okay, to start BatQ, you have to install it. So I already created a video about how to install BatQ. You can refer to it. Quickly though, to install or to use BatQ, you need the Batfish server and you need another machine to run the Streamlit app. Uh, Before you start, you have to set your Batfish server address in the environment variable as an environment variable, and then you execute the command written in this screen Streamlit run home. Home is the starting page for BatQ. Once you do that, you get this screen here, and you will see here there are 5 pages: the home, questions, analysis, failed test, and differential. Okay, so these are the page. Each one of these pages will do a different job. So home will let you uh, upload the configuration files. We call them in Batfish terminology, we call them snapshots. So the snapshot is the current state of the network as represented by the configuration files. The questions allow you to ask questions. The questions are the way you interact with Batfish. So Batfish builds a data model for the network, and then you ask questions, which are basically functions, Python functions. So you ask questions and you get the response. So in this questions page, you select the questions and optionally you put some parameters if they need parameters. The analysis page will give you the answers to the questions. Batfish allows you to test failure scenarios. So in the fail test page, you can select whatever you want to break, like a router or an interface, and Batfish will give you the answers to the questions given that you have some components failed. Differential page is another feature of Batfish, which allows you to compare two configuration sets, two snapshots. So let's say you have a configuration, old configuration of the network, and then you make some changes. So in this page, you can find what is the difference between the first configuration and the second configuration in terms of behavior, not in terms of just lines of code, but in terms of behavior. So all of these are the things that we can do with BATQ. Okay, so the simple workflow for BATQ is to go upload the snapshot and then select the questions and then deanalyze the network. And you can go back and upload another snapshot or modify the question. So you can go back and forth between these three components. Also, you can optionally go and do failure test or do comparisons. So we're going to focus mostly in this demo on these three steps. Okay, so for this demo, I am going to test a very simple network. So in this network, I have a workstation connected to a switch, connected to a router. This these three components represent a customer network, organization network. R1, the router is connected to an ISP router through a link, and the ISP router is connected to the rest of the ISP network. So this is the physical, the top diagram is the physical connection. The bottom diagram represents the logical network where you have a segment here, 192.168.1.0/24. This is the LAN segment. The switch, the router and the workstation are connected to the same segment here. Then there is another LAN segment that represents the link between the two routers. One good thing about BATFISH and also BATQ is that you can represent not just the routers but also the workstations and other components like the ISPs. So you can provide representations of the hosts and some other components like an ISP network. So the entire internet, for example, I can represent it in BATQ with a file. All right, so let's see what we can do here. Okay, so back to BATQ here. Before I start, I'm going to show you the configuration files. The configuration files for BATFISH must be divided into, or must be in a specific folder structure. So you can start, you see here, I have multiple networks. I'm just going to start with net A initial here, which is the one that I'm going to use for demonstration. And purposely, I introduced some errors in the configuration just to see how BATQ can show the errors and we can troubleshoot the network. Inside the main folder, we have three folders. The configs is the one that required, it's must. And you see here I have three configuration files. The configuration files are Cisco configuration files. So the first one show the configuration of the switch. I have two ports here. One port is supposed to go to the workstation and one port is supposed to go to the router R1. I have another configuration file that represents the configuration of router 2, and I have another configuration for router, the ISP router, ISP R1. So these are the three configuration files that you need. But then I can also represent hosts. In BATFISH, you can represent a host with the JSON structure here. So the host name is WS1 and it has interface Ethernet 0 and it has the IP address and the gateway. So this is how you represent a host. You can also represent um, the ISP itself. So I'm using this is the JSON file that represents the ISP. So I have a border interface, and the border interface is connected to the router ISP R1 through interface gigabit Ethernet 0/1. I'm gonna skip the details in this demo, but you can go to the documentation and see the details and how you build these files. I may use other recordings to go deeper into these details. Um, Badfish does not know how to build the physical topology. It can build or understand or infer the logical topology from the configuration. But physically, the physical connections you need to provide Badfish with the details. Not necessary, I mean, this is optional. But if you want Badfish to understand the physical connections, so you have to provide another JSON uh, structure here that tells Badfish the edges. So this is the all the edges, physical edges in the network. So you have node, the workstation connected to the switch through the interfaces listed here, and the switch connected to router 1 through interfaces, and router 1 connected to the ISPR1 through the interface. So this is a list of all the physical links in the topology. All right, so now we have all of these structures. We need, so this file or this folder represent a snapshot, represent the configuration, the current configuration of the network. In order to upload this to BATQ, I need to configure, I need to zip those files, right? So I'm just going to zip the file. So create a zip file and then upload the zip file. Okay, so now the zip file is uploaded, and I have here the snapshot listed. Usually I can include two snapshots for comparison if I need later. Right now it shows that the main snapshot and the alternate snapshot is the same, so I don't need to do that right now. So I'm gonna go to the next step, which is selecting the questions. There are many questions available for Badfish, about 70. They are divided into categories for easy, easy use. So each one of them, if you select the description here, tells you what each one of these categories do. So I'm going to select, you can select as many questions as you want to. But just to make the output clear, I'm going to select few questions at a time. So the first set of questions, usually this is where I start. These questions um, tell me if Badfish understood the configuration files, right? So I want to make sure that Badfish actually understands the configuration files and there is nothing that is missed. Now, there are possibilities. Badfish may not be able to recognize certain lines in the code, or may not be recognize certain vendor configuration because it doesn't support everything, right? So I want to make sure that everything is understood. So I'm going to select, for now, I'm going to select all three. Each one of these questions actually have a slight purpose, but I'm going to go through them one by one. So now I selected the question. You can see here the options. So most of these questions don't have options, but snapshot, input file, parse warning, it has some options here. I'm going to ignore them. I'm just going to go through If you ignore them, that's fine, because most of these options are, or most of these parameters are optional. So if you don't put anything in here, nothing will have nothing. There is no problem. If you see an asterisk next to the name, then this parameter is required. So we'll see an example of that later. All right, I'm going to jump to analysis right away. Remember, I mentioned that I created intentional errors in the configuration files. So let's see. First one, here in the snapshot input file parse status, you can see the file names that Batfish read and the status. So they're all passed, which means they all read fine. And it recognized the format. It recognized that for the first three files, they are actually Cisco IOS files. And the last one, the workstation one, is actually a host. All right, so that's great. Let's see the warnings. There is a warning here that says in the configuration file ISPR1 .text, there is this text that Batfish did not, or actually found an error in it, right? So what is the error? The error in the comments here, error fetching interface name, invalid interface name prefix. If you look closely, you see that the gigabit Ethernet is actually missing E, right? So Batfish was able to recognize this is an interface, but it's not the right interface name. All right, so now this is one good example of how Batfish can detect errors. All right, so that's an error. And then we have, in this question, there is initialization issues. Initialization issues usually refers to a failure to recognize certain lines, right? So it sees a line, but then something is not right from Batfish point of view. So I'm gonna ignore the first one because I know where this is coming from, and I'm gonna look at the second one, which is node R2 here. It says that ignoring NAT rule with undefined access list 1. It seems like, okay, Batfish read the, the configuration and it's ignoring this rule. Why it's ignoring it? Well, we'll see. I don't know yet, right? Or it's not clear from this line. And then you see another warning, which is the same as the one that we saw here. The interface name does not make sense. It's missing an E. All right. Okay. Now I should go and fix this error right away. But I'm gonna ask more questions just to demonstrate here. So another category has the name or has it's a topology category where I can show layer 3 topology and layer 1 topology or layer 1 and 2 topology. So if I go back to my analysis here after selecting those, I'll see that layer 1 topology is extracted from the information that I gave to Batfish. And it shows here workstation 1 connected to switch 1, connected to R1, connected to ISP. So it's exactly like the one that I showed you earlier, which is here. All right, so that's good. How about layer 3 topology? Layer 3 topology shows router 2 connected to the workstation 1, right? But I don't see the the ISP router. So there must be something wrong here, right? Why don't I see the other router? And you can see in the list here, R2 gigabit Ethernet 00 has this IP address, and the remote interface it's connected to the workstation 1 Ethernet 0 port, and so on. All right, so you can see the lines here. Now, before I go any further, I know there is an error, which is the interface name. So let's fix that error first. To fix that error, I can go back to the files, and let's see, I'm going to change the I think it's going here, so I'm gonna put E, save this, and create another zip file. All right, I'm gonna go back to the snapshots, the home, and I don't need to delete the old one, it can override it. So I'm just going to take the snapshot again. So upload the configurations again. All right. I didn't touch anything else, so the same questions remain. So I'm gonna go back to analysis. The analysis shows past everything. The warning, there's no warning. So here the answer is empty, means that there is no warning. Okay, so usually this is not always, but usually this is a good thing, right? So no warning, that's great. But I still see a warning here. So one warning disappeared, but there is this NAT rule that's still there, right? Let's go back to the topology. I have this physical topology working fine. Logical topology is still not working. Okay, so there must be some other error that I haven't discovered yet. All right, so what could be the error? Now this introduces me to, or let me introduce you to a new set of questions. One of these questions, they are configuration properties, and you can see a big list of configuration of questions. I'm gonna pick the interface properties and also something called IP owners, right? I'm gonna delete these for now, and maybe even some of these, and go back to the analysis. All right, so let's see the interface properties. Now, if you are doing this in a production network, in a real network, and you see maybe you cannot see the connections between two routers, what do? You go check the interfaces, you go check if the link is actually functioning between the two routers. So here, based on the configuration files themselves, I can look at the interface, look at its properties. So the interface here, I have all the interfaces in the network to the left side. VLANs, I have no VLANs here except VLAN 1, which is default in the switches. They are all active, they are all admin up, and their interfaces or their prefixes or the IP addresses are listed here. I can see right away there is duplicate IP address here. These two are duplicates, which why they cannot talk to each other. There are more properties if you want to look further, the speed. These are switch port, you can see here, switch port mode access. So there are a lot of details here. And one thing that's still missing from BATQ is the ability to filter. I can filter based on properties. So I can filter, let's say, well, this is probably a good example that I can do. So I can filter based on some of these parameters by going to the options, but I'll leave that to later. Okay, so now I discovered that I have two interfaces with the same IP address. All right, so another question detects this easily. So the IP owners here also the purpose of this question is actually tells me the IP addresses in the network and who owns them, which interfaces they belong to, and which node they belong to. So it's more focus more on the IP addresses. So the IP address here, you can see these two are identical. And actually there is an option that allows me to show only the duplicates, right? But for now, I'm just going to focus on using the default parameters, but you can actually add a parameter to the IP owner's question to show only the duplicates. So if you want to test for duplicates, you can do you can do that right away. Okay, so I have duplicates here. So I'm gonna go back and fix that. So let's see for router 2, I'm gonna change this IP address here and leave this as 1. So I'm gonna go back and change this to number 2. While I'm here, actually, probably you noticed an error, intentional error. The file name is r1.txt while the host name is r2. Right? Badfish does not care, it just picks this one, so all the labels for the routers will be R2. But just to make things consistent for me and less confusing, I think the file name should be the same as the router name. So I'm gonna change this to hostname R1. All right. So same as before, I'm gonna create a zip file. By the way, if you are using Badfish and Python directly, you don't have to zip the files. The zipping the files is actually needed for BadQ because I cannot grab the whole folder. So I'm zipping it, so it will be just one file. Okay, now I can go back and upload the zip file again. So now remember the zip file will include the correct IP addresses. All right, so if I go to the interface properties, the IP owners, now everything is correct. There is no duplicate. Let's go back to the questions about topology and see the topology now. Layer 3, remember the layer 3 topology was not correct before, so let's see now if it's correct, and it is, right? So now workstation 1 is connected at layer 3 to router 1. Of course you don't see the switch because it's layer 2 device, so you see workstation 1 connected to R1 connected to ISP R1. So, and the table here shows the same details, the interface, its IP address, and the remote interface. Great. Okay. Now, if you still remember, we still have this warning, ignoring NAT rule with undefined ACL1. So what's going on here? Let me see. The error or the warning comes from router 1. So let's see what's going on with router 1 and why it's causing this error. So if you go to router 1, I see the error happens. Actually, if I select the other question, it tells me exactly which line the error happens in. So the parse warning, I go back to this one, it tells me, no, actually it doesn't. Yeah, the warning, because it just ignores it. So ignoring NAT rule with undefined ACL1. If I go to the configuration, well, I have this rule here. But I'm gonna pretend that I didn't see that, and I'll ask another question. Now I have no problems with the configuration with the interfaces, but there is other question. You see here named structures, defined structures, reference structures, undefined references, and unused structures. So I'm going to select these two and let you know what they mean. So undefined references is a question that asks the configuration, what are the things, like the things could be, the structure could be anything, including an ACL, including an access list, that it's defined, that is used, but not defined, right? And also the unused structure is the opposite, the things that are defined but not used. So let's go and look at these two. Undefined references, it says here that in line 15, there is an ACL one ACL1 that's used but not defined. Okay, and then we have unused structure. There is a structure name, a structure access list, that's the access list 11, that's actually not being used, which is in line 19. Let's go to the configuration and look at these two. So in line 15, we have access list 1 that's used but not defined. We have no access list 1 here. And in line 19, we have an access list 11 that's defined but not used. Obviously, the two, if you combine the two together, I'd figure out that, okay, so there must be a typo here. So it's either this one is 11 or this one must be 1. So I'm just going to remove. So now this is a consistent configuration where this is a NAT line here that says anything that matches list 1, use the IP address of this interface as a NAT. So okay, so this configuration should work right now. So I'm gonna go do the same thing, delete this one, and compress, read the configuration. So this is the new configuration right now. And let's go to the analysis and see if there's any more. So unused references or undefined references, nothing. Unused structures, nothing. So okay, so everything in my configuration is defined and used. All right. If I go back to the initialization issues, I'll find that there is nothing here. That warning has disappeared. As I said, this particular warning, I know what it is, and it's the detail is outside the scope of this demo, so I'm not going to talk about it. Notice something here that BATQ, because sometimes the tables are huge, so BATQ tries to make the table smaller by ignoring all the columns that have nothing in them, right? They are empty columns. So there are columns called line text, source lines, parse context that are empty. They're all empty, so BATQ just simply does not display them, but it tells you about them just in case you're you wanna be aware that some columns are not listed. Okay, so now I almost sure that all the configuration is correct, but I want to know that my configuration, well, the syntax is correct, right? So the syntax is correct. Everything is checks out from the syntax point of view. But does the network work? If I go back to my network here, um, my goal is to allow the workstation to connect to the ISP. So will this configuration work? So for that, I need to switch uh, to a different set of questions. So I don't need this anymore. Let's ignore these, cancel them. And I'm gonna come to the routing and forwarding tables, which is another set of questions that let me know, for example, all the routes in the network. And I don't have a lot, all my routing is done using static routes in this configuration, so I don't have any details about different routing protocols. But if I want to know about routing protocols details, I will ask these questions. So routes will be one question that I want to ask, and also packet forwarding. But I'll just skip right now and just go to the routes. The routes question will give me all the routes that are reachable by all the nodes. So, for example, the node ISP-R1, which is the ISP router, it has the default route that's pointing to 1112, which is the rest of this is the representation of the rest of the internet, right? And also it has another route that points to the customer router. And you see here if it's static, if it's connected, if it's local, and so on. This is the protocol, and this is the next hub interface, and the administration status, the admin status. For router 1, you can see all of the details, and for workstation also it has a default gateway that's pointing to R1. This is a good example to um, check the parameters. So if you see here, I used this question, and automatically you can see all the options that you can put to the right side here. So the input parameters for this questions are nodes, network, prefix, match type, protocols, VRFs, and RIP. I'm just going to focus on R1, right? So this means that just give me the routes for R1. It's kind of filtering, right? So if you go back to the analysis, you will see that I filtered the output for R1 only. Okay, so it looks here that I have all the routing correct. So let's ask another question. Uh, so usually what you do in a real network or in a lab is you ping or you do trace route from the workstation to the internet to see if packets go. So I have the equivalent here. I have trace route, which is unidirectional in this case. For Batfish, trace route is unidirectional, but I have another one called bidirectional trace route. So I'm going to select this one first. I'm going to go slowly. For trace route, it has actually mandatory options. The first mandatory option is where you want to start your trace route. So I'm going to start with workstation Ethernet 0. So that's the node and the interface. The details are in the documentation. I just memorized these, but the details are in the documentation. So the actual syntax that you should use, it's in the documentation. And I'm going to skip that for now. And maybe another tutorial will dive into the details. For the headers, I want to, this is the packet header. This specify what the packet header looks like. So that's why it's called headers. And also you have to know the exact syntax, but in my case, so it's the destination DST IP. You write it, by the way, as a dictionary, as a Python dictionary. So I'm gonna pretend to trace route to 888. This is the minimum. You can add more details in the header, but this is the minimum. Okay, so if you go to the analysis right now, actually probably I made a mistake in the format, and let me double check the format. Yes, yeah, there must be IPS here. There is an S missing. Actually, you can, that means that you can put more than one IP address. All right, so now we go back to the analysis, and it says the answer set is empty. I should see something. And I don't see anything because it's actually the starting location is wrong. I have to put WS1. Okay, so let's see. Now we're working. Okay, so now it's well, it's my fault. So you can see the trace route here, and it's interesting trace route. It's not like the trace route that you do in the one that you know about, but it's actually a lot more detailed. So let's start. First of all, the output or the ultimate result you will see here as this position. So the result is the packet exits the network. All right, so great. Exits the network means that it goes to the internet. Anything that outside the scope of the configuration, it says exits the network. So it means that the packet left the configuration that you provided, left the network that you defined. Right? But let's see, the start is workstation 1, type originates. So the packet originates from workstation 1, and it's forwarded here to 192.168.1.1. Interface Ethernet 0. There are a lot of details here, right? Some of them I'm gonna skip, but there are a lot of details if you, that allows you to troubleshoot everything. Finally, the network is transmitted and it exits through the interface Ethernet 0. Where it goes next, it goes to, from layer 3 perspective, it goes to router 1. So it's received on router 1, received in the interface gigabit Ethernet 00, and it's routed to 10.10.10.1, which is the ISPR1. And there is something that happens after routing, which is the NAT. We have to NAT, so there is this transformation here. So you see here that the source IP new value, of course, the NAT will change the source IP. So the new value is 10.10.10.2. The old value is the address of the workstation, which is 192.168.1.2, right? And the type of the NAT is the source NAT. There is the setup session here, and then it exits the output. It exits through interface gigabit Ethernet 01, and then goes to the ISP, also received through which interface? This one, and then it's routed to 1.1.1.2, and then finally it exits the network through this interface. Okay, so traceroute works, and it gives me a lot of details. But traceroute is one directional, so I'm going to use another question that gives me bidirectional traceroute, which is this one. It has similar parameters, so I'm just gonna copy and paste these two questions, these two parameters here. All right, and I'm gonna go to the analysis. So I have two flows. The first flow is the forward flow, and the destination is 8.8.8.8. By the way, the default protocol for traceroute is UDP, so I show UDP here. Packet length, all of these are things that are generated by Batfish, and you can change them. You can change the details if you want. The source IP is this one, and then we have this output, which is identical to the output that we saw in the traceroute. The thing that's different is actually the reverse. The reverse is reverse flow is something that's coming from the internet back to the workstation. So if you see the detail, you see that the packet eventually is accepted, which is good, and the packet in the way back, it comes to the router ISP-R1 through the interface from the internet. It's routed, it exits the interface through to router 1. So router 1, there is a match session for the NAT. Remember the NAT, we did the established session before. Now it matches the session and it's transformed. Now we're doing the destination NAT. So it's natted back to 192.168.1.2, and then it's routed. It exits router 1, it heads to the workstation, and eventually it is accepted by the workstation. So now we confirmed that our network works fine by trace route from the workstation to the internet and back. Okay, that's pretty much it for this simple network. I can add more details. For example, I can change the protocols. So instead of the default UDP, I can change this to TCP, for example. So I can type IP protocols and I choose TCP. This would be good if I want to test certain access lists, right? Maybe the network or the traceroute will work fine for UDP, but not for TCP. So I want to double check that. And okay, so it works for TCP as well. If you look at the it still shows UDP, so let me double check if there's something wrong here. Oh, of course, something wrong because I changed it in the traceroute, but I didn't change it in the bidirectional traceroute, so I have to change it. I don't have to change it in both cases, but I just want to have consistent results. All right. So here for the bidirectional traceroute, now I have the IP protocol TCP as expected, and you notice here the destination port is 80, which is common for TCP, of course. If I want to change that, I can. Source port is picked randomly, so the result will be the same for UDP. Okay. So far so good. Now let's do some failure testing. So for failure testing, I can go to this page and it gives me options to either fail a node or fail an interface, or both if I want to. So I'm just gonna make switch 1 fails, switch 1. Now immediately the trace route says empty, which means I cannot reach the internet, and also the bidirectional route is empty, so I cannot reach the internet once the switch fails. What if I make the ISP router fails? So the ISP router fails means that the packet will go all the way from the workstation to the router one, but then there is no route. You see here the disposition, there is no route. So it stops. It cannot reach the internet. Same with the bidirectional. You see there is no reverse flow, and the packet will go all the way to the router one, and then you cannot route it anymore because the router failed. Okay, let's fail an interface. So for the ISP, there are two interfaces, one that's pointing to R1 and the other one is pointing to the internet. So let's fail this one and see what happens. Same thing, here the packet will go further, will go from the workstation 1 to R1 to ISP R1, but then it stops and the packet is discarded because there is no routing for it. And same thing for the bidirectional, of course. All right, for differential, I need to have two uh, snapshots. So if I go back to the home, I can either upload a new snapshot or automatically I can check the fail. So BATQ automatically, once you fail any node or switch, it creates a snapshot that has the same name as the original snapshot with added suffix here, which is fail. So now I have two snapshots. Differential and see difference between the two options. So for bidirectional trace route is a little bit too long, so I'm gonna just focus on the just one directional trace route. So you can see here the reference trace, which is the first one, the original one, is complete and the packet is exits the network. The second one is not complete and there is no route. I can also select maybe different questions to illustrate the difference between the two. So if I check the routes here and I go to the differential, and here is a good example of the difference between the two snapshots. So if you look, um, you see that the difference is in the ISP R1. Everything else is the same except for the node 1, and you can see in the reference the routes are only in the reference but not in the other one. They're not in the alternate snapshot. So the routes, there is a default route to this IP address 1.1.1.2, and there's all this information, but when you see only in reference means that the other snapshot, the failed snapshot, it doesn't have the same thing. So here it's a quick glance on what are the differences between the two configuration sets. All right, so this is a really short demo, and it doesn't really show the actual power of the differential page. But I think for now, this is all I'm gonna talk about. I hope that got you interested in using BATQ and learning more about BATFISH. Thank you for watching this video and hope I can see you in another one.